So hello everyone, let us solve another LeetCode problem, and the problem name is minimum cost to convert string part 1. So you are given two zero indexed strings, source and target. Both of them have length n and consisting of lowercase English letters. You are also given two zero indexed character arrays, original and changed, and an integer array cost, where cost of I represents the cost of changing the character original I to changed of I. So what the question is saying that you are given a string source, you are given a string target, you are given an array original, you are given an array changed, and you are given an array cost. Now in this original there might be some characters like A, B, C. Here also there might be some characters like B, C, A. Now to convert this original character A to this changed character B, there might be some cost, which is, let's say, X at this index I. So this is also index I, this is also index I. So to convert original, so this is original of I to changed of I, it will require a cost of I. So this is what the question is saying till now. Now you start with the string source. In one operation you can pick a character X from the string and change it to character Y at a cost of Z if there exists any index J such that the cost of J is equal to Z, original of J equal to X, and changed of J equal to Y. The same thing that I have told here, this is what they have said. Now in the end you need to return the minimum cost to convert string source to string target using any number of operation, and if it is impossible to convert source to target, then we need to return -1. So what the question is saying that in the end, with the help of these transition from original to change, it will require some cost, right? So with the help of these transitions you need to change this source string to the target string with the minimum cost possible. So here we don't need to care about minimum operations, we need to take care about the minimum cost. And if it is impossible to convert a source to target, that means we need to return -1. And in which case it will be there, it will be happen only if in source there might be some character A and its position should, and its actual character should be B. That means in target it is actually B. So if directly or indirectly there is no transition from A to B, that means in this case we'll be returning -1, because if we can't convert even one letter in source to target, that means it is not possible to convert entire source string to target string. So in this case we'll be returning -1. So this is what the question is saying. So let us see with the help of first example how the flow works, how will we get the answer and all of that. So you can see in the first example the source string is ABCD and the target is A, C, B and E, and this is the original and changed. So this is original A, B, C, E and D. This is E. Okay. Now the changed is B, C, B, E, B and E, and their corresponding cost is 2, 5, 5, 1, 2, 20. So first we will take this 0th index. So in this case already the source is equal to target, so we won't apply any operations, because if the strings are already matching there is no need to apply operations, because that will only increase the cost if we apply the operation. So in this case we will just move on to the next index. So here it is B and here it is C. That means we want to transition from B to C. So we will check, okay, this is B in the original and this is C in the changed part, and it will cost 5. So we will add 5 to our cost. Okay. Now we will move on to this C and B. Now here it is C and we move on to B. So we want to go from C to B. So here you can see it is C and here you can see it is B. So we will add 5 to our cost because it will cost us 5 for this transition. So till now we have 5 plus 5 as our total cost in order to convert source to target till here. In the end we have this D and E, that means we need to convert D to E. Now here if you see D to E takes cost of 20, so we will add 20 to our answer. So in total how much cost is required? 5 plus 5 is 10, 10 plus 20 is 30. So in total, to move from source to target we will require cost of 30. And is it actually the minimum cost? Let us check. So the output here is 28, but we are getting 30. That means we can reduce this cost to even further. So how we will reduce the cost? Because we have seen every transaction B to C, C to B and D to E. So how we can reduce the cost further? So we can reduce the cost further with the help of one simple observation. So if you observe this example carefully, so let me just redraw this example so that you can observe it in more better way. Now the observation here is we are doing this transition, we need to convert C to B. Now we have chosen this path C to B, it will take cost of 5, but it is not the only transition that we can help us to go from C to B. You see, if we go from first C to E, we go from C to E, it will cost us 1. From E to B, if we go from E to B, it will cost us 2. So indirectly we have converted C to B with the cost of 3 only. So here previously we were getting 5, but now we are getting 3. So this is the main observation. There can't be only one way to go from one character to another. There can be multiple possible ways to go from one character to another, either directly or indirectly with some intermediate nodes in between. So this is the observation. So from all the possible path, we need to choose the minimum path. So this gives us the idea that we have many possible paths, right? From C to D, we can have many possible paths, but in that we need to choose the minimum path. So minimum path, shortest cost, this gives us the idea of Dijkstra algorithm, right? Because what we can do, we can treat this entire thing as the graph, and for this graph we can what we can do, we can just apply Dijkstra for each and every character, right? So let me show you what I am saying. So first of all, we will make a graph for this particular array. So here we can see A is going to B with the cost of 2, B is going to C with the cost of 5, C is going to B with the cost of 5, then C is going to E with the cost of 1, E is going to B with the cost of 2, so E is going to B with the cost of 2, then D is going to E with the cost of 20. So here might be some D and it is going to E with the cost of 20. So you see, we have created a graph. Now this is the same thing. From C to B there will be two paths. Either you can go to C to B directly with the cost of 5, or you can what you can do, you can go to E first with the cost of 1, and from E to B you can have a cost of 2. So in total, from going from C to B, it will cost you 3. So this is the main observation. So we can just apply Dijkstra on this particular case. So let us see how we will be getting answer 28 with the help of this simple graph analogy. So the original string was A, B, C and D, and the target is A, C, B and E, right? So A and A are equal, so don't need to apply any operation. Now B to C. Now B to C, you see there is only one path, so we need to apply 5 operations. So here 5 is the minimum output that we can get. So for B to C we have cost of 5. Now from C to B, either we can go directly from C to B with the cost of 5, or we can first go C to E and then E to B with the cost of 3. So one cost is 5, which is directly from C to B, and the another cost is C, which is the another cost is 3, which we can get by going from C to E and then E to B. So which is minimum, because indirectly we are getting to B only in both the cases. So here 3 is the minimum, so we will add 3 to our answer. So from C to B it will cost S 3. Then we have D to E. we need to convert D to E, and again D to E has only one transition, or there is only one path, so it will take cost 20. So we will add 20 to our answer. So the final cost will become 20 plus 8, that is nothing but 28, and that's why you can see our output is also 28. So we will use this Dijkstra algorithm thing here in order to solve this particular problem. And if you are new to Dijkstra, let me show you how Dijkstra algorithm works. So Dijkstra algorithm takes a distance vector. That distance vector stores the minimum distance from source node to each and every node, right? So let's say you are at currently node U and you are going to node V, and it will cost some weight W. Now this distance of V or distance of U will store what is the minimum distance to reach node U from the source node. So let's say the source node is 0. So from 0 to U, what is the minimum distance? That is what this distance vector will store. Now for there is one base scenario. If what will happen if the source node is 0, and what is the dist of 0? So dist of 0 will be 0 only, because going from source node 0 to 0 itself, it will cost us 0 only. So for this particular scenario, the cost will be 0, and for every other scenario we will have some cost. So this distance vector will keep the minimum cost to go from source 0 to any other source U or V, whatever. Now we need to go from node U to node V, and it has some weight W. So what will be the minimum distance to go from node 0 to node V? That is what we need to find out, right? So in order to go from 0 to V directly, first we need to get the minimum distance from 0 to U, because if this distance is minimum, then we just need to add this W to our whatever this minimum is, and if we add this W to this minimum, we will obviously get this entire thing minimum only, because this W is fixed given by the question, and this we are taking minimum. So this minimum will be given with the help of min heap that we will be taking. So if we have the node U at the top, then obviously whatever the distance it has, it will be minimum only. So first of all, what we will do, dist of U we will get, and that in that particular dist of U we will add weight of U comma V, and we will check if we have already stored some value of dist of V or not. So whatever this answer is, let's say this X. Now if this X is less than dist of V or not, so let's say dist of V was already storing some value which says that okay, this is the minimum distance to go from 0 to node V. Now if we got a new distance which is lesser than this dist of V, that means we need to update this dist of V. So what we will do, we will update this dist of V so that we can get the new minimum to reach node V from the source node 0. So dist of V will now store dist of U plus this weight of U comma V. So this is how Dijkstra algorithm works. We keeps on updating the minimum distance to reach to a particular node from the source node, and we use a min heap so that whenever that particular node comes into our heap or the min heap, we will always get this minimum distance possible for this particular node V. So this is how the Dijkstra algorithm works. So if you have no idea of the Dijkstra algorithm, so this is how the Dijkstra algorithm actually works. So now how will we apply this Dijkstra algorithm in our question? Because we will have multiple source, right? From A we need to find minimum distance to B, we need to find minimum distance to C, we need to find minimum distance to E, so on and so forth. From B we need to find minimum distance to A, from B we need to find minimum distance to C, from B we need to find minimum distance to Z, so on and so forth. So you see, we need to run this particular Dijkstra algorithm multiple number of times. So what we are doing here, this is the source. This is the source. So we will run Dijkstra algorithm 26 number of times for each and every character in our English alphabet range. So we will have total 26 alphabet in our English letters from A, B up till Z. So we will take each and every character as the source node, and from this source node we will find minimum distance to every other node. from B, C up till Z. So that is how we'll be applying the Dijkstra algorithm. So you can think it of as a multi-source BFS, because Dijkstra algorithm indirectly uses BFS only. So now how do we do in terms of code? How do we store this minimum things and all of these things in our some data structure, so that we can get those answer or the minimum cost efficiently? So running the Dijkstra algorithm is easy. That is the same thing. Dijkstra algorithm just returns the distance array or the distance vector, which will tell us what is the minimum distance from source node to each and every node that is present inside the distance vector. So Dijkstra algorithm returns this. Now here we will have multiple source, and for each and every source we will have a particular distance vector. So you see there is one kind of mapping. So what we can do, we can create a map of integer comma vector of int. This integer will be nothing but the source, and this vector will be the nothing but the distance vector which Dijkstra algorithm returns. So this will be nothing but the distance vector which the Dijkstra algorithm returns. So what this map will tell? This map will tell, okay, for A I have this distance vector, for B I have this distance vector, for C I have this distance vector, and so on and so forth up till Z I have this distance vector. Now in this distance vector, what will be storing? The index value will be something like this. Now this index will represent the actual characters like A, B, C, D. Now this distance vector will tell us the minimum cost to reach a particular character, let's say B, from this source node A. So from going from A to B, it will cost us 3, or the minimum cost is 3. Similarly, if the source is B, we need to reach A, the minimum cost is 4. So from source node B to this destination node A, the minimum cost required is 4. So this is how we'll be storing the entire thing in our map. So the first thing will be the source node, and the other thing will be the distance vector. This distance vector stores the minimum distance to each and every node from this source node. So this is how we'll be storing these things. And now how will we run the DFS, or how will we run the DFS? So it is simple. For we'll be running a loop from 0 till 26, and we'll be just running this BFS, or you can say Dijkstra, for this particular ith character. And whatever this thing returns, this thing will return a distance vector. So what you can do, we can store mp of I equal to this distance vector. Now this I is nothing but a source node. For this source node, we are running a Dijkstra which will return us the distance vector, which will say, okay, from the source node to each and every node, what is the minimum distance possible. And for this source node, we are storing this distance vector. So the same thing that I have told you above. For this source node, we are storing the distance vector. And if we have the minimum cost from one node to each and every node, from one node to each and every node, from one node to each and every node, so we can just look up into our map to convert a particular source character to a target character. So what I am saying, we'll have some source, right? We'll have some source and we will have some target. Let's say the source is A, B, C, D and the target is B, C, D, E. Now let's say we need to convert A to B. So in this, what we will do, we will say, okay, the source is A and the destination is B. So that means we need to look for A character in map. So A character in map will return what? It will return the distance vector. This distance vector will be storing the minimum distance to reach to each and every node from the source node A. This is how it will look. So this is how the distance array will look. Now B is what? B is 1. So let's say it is 4. So MP of A will return the distance vector for this source node A. Inside this distance vector, we need to find what is the minimum cost of B. So in this vector, let's say this is the distance vector. In this, we will search for B. So distance of B. So this is how we'll be returning the minimum cost to convert or to go from one node or to transition from one node to another node. So this is how we'll be doing this particular problem. So let us see in terms of code, you will understand in more better way. So this is the code. So first of all, I am declaring the n as the size of the original array, and also I am declaring the graph. This is the graph, adjacency list. So I am first creating the adjacency list. It is simple. It is the direct connection. It is a kind of directed weighted graph. So what we are doing for this original node, what is the transition with the cost of I? That is what we are storing. So let's say this is A, this is B, and let's say this is C. So it is storing like this: A to B, the cost is 3. So this is how we are creating the graph or the adjacency list in terms of adjacency list. Now we are creating a map. This map is nothing but what we have seen. Map will store integer comma vector. This vector will give us the distance or the minimum distance from this source node to reach every other node. So this will be storing the source node, and this will be storing the distance vector that we'll be getting from running the Dijkstra algorithm. So this is the map that we are creating. Now for each and every source node, we need to find all the minimum distance to all the other nodes. So this is what we are doing. So this will be giving us the distance vector by running the Dijkstra algorithm, or you can also say BFS, because Dijkstra is indirectly running BFS only. So you can treat this as a multi-source BFS, because from multiple source node we are running this BFS. So you can say this is a kind of multi-source BFS, and this BFS or this Dijkstra will return us the distance vector. So we are just storing distance vector in terms in front of this particular ith character. So this is what it is doing till now. Now how this Dijkstra algorithm works, let us see now. So Dijkstra algorithm takes the min heap so that we can always get a minimum distance for a particular node, and then first whatever the source is, the distance from source node to itself will be 0. So first of all we are doing that. For the source node, the distance will be 0 only. So that is what we are doing. Then we are initializing the distance vector. Everything will be initialized with int max, because we need to find the minimum distance. So to compare it with the minimum distance, we need to initialize it with the as max value as possible. So that's why we are initializing it with int max. Now the distance from source node to itself will be 0. So we are doing that only. Now we'll be running this priority queue or this algorithm until our priority queue becomes empty. So first of all, whatever this character is or the node is, we are getting that and its corresponding distance, and then we are popping it out, and then we are going to each and every adjacent node to find what is the minimum distance to reach this particular node V from this particular node U. And to reach from U to V, first we need to reach 0 to U. So this distance is nothing but going from 0 to U. This will give us the minimum distance, because priority queue always give us the minimum distance on top. And to reach from U to V, it is nothing but the weight, and this will indirectly give us the minimum distance to reach from 0 to V. Now we will check this dist of adjacent node is what? This dist of V. This dist of adjacent node is nothing but this, it is dist of V. So if we already have some dist of V's value stored in our distance vector, we will check whether this new distance is lesser than this previous distance or not. If it is lesser, then we will update this previous distance with this new distance, because this is the new minimum. And then in the priority queue or the main heap, we will get this updated distance. So we will put this updated distance into our priority queue or the main heap for this particular node V, and this will keep on going until our priority queue becomes empty. So this is how the Dijkstra algorithm works, and in the end we are just returning the distance vector. So for this particular source node, we have our distance vector ready. So what we are doing further, we have our source node and its corresponding distance vector, right? Now we just need to look up into our map for every transition. So let's say the source node is some, or the source string is, let's say A, B, C, and the target is, let's say C, B, D. So to convert A to C, we just need to look up into our map. So what is the source? Source is A. What is its corresponding distance vector? We will get that. And for that corresponding distance vector, we will look for the C character in this distance vector. So whatever this distance vector corresponding C value stores, it will be the minimum distance only, because we have got this value from Dijkstra algorithm, and Dijkstra always gives us the minimum value. So this value will be minimum only. So we will just say, okay, this will be the minimum value or the minimum cost from A to transition to C. So this is what we are doing. We are running a for loop, and also we are keeping a variable c which will tell us the minimum cost to convert this entire source string to target string. So we are running a loop for this source string, and if we will check first if the source and target are already equal, we don't need to apply operation, so continue. Otherwise, what is the source that we will take, and that we will name it as from. We will convert it into integer because this distance vector is all this indexing is based on integer only. So for a the integer value will be 0, for b the integer value will be 1, so on and so forth. And for target we are naming this corresponding integer value as 2. Now first of all we need to look up for the distance vector for this from. So we will say a is nothing but, or the distance vector is nothing but mp of from. So we have this source node and its corresponding distance. So for this source node we need the distance vector, right? So we will search for mp of from. This will give us the corresponding distance vector for this source node. So we have this distance vector. Now in this distance vector we need to look up for the 2 value. So let's say in this case the 2 value is c. So we will look the distance of 2, right? In this case the distance vector is named as a. So we will check a of 2. So a of 2, if it is already equal to int max, that means there is no way we can reach from source to this destination. That means we need to return -1, because even if we are not able to convert one character to another character, our source will not be equal to target. So we will be returning -1 here only. And if it is not equal to int max, then simply return or simply add this a of 2 or the distance of 2 value to our cost or the total cost. So keep doing this for each and every source character. In the end we'll be converting the entire source string to the target string. So whatever cost it will take, we will just return that. So this is how we'll be solving this problem. So I hope you understand this problem. Thank you for watching.